Okay, so we're going to look at a quick example showing how to hex mesh a compound fillet. So this is a piece of geometry that's been generated that's sort of representative of a compound fillet. So that's a fillet where you've got surfaces meeting, fillet surfaces meeting at an intersection point, and traditionally this has been difficult to deal with from a hex mesh perspective. So we're going to look at the 2.5D meshability. So by default the geometry has come out as red, so it's not 2.5D or hex meshable. So we're going to use a split tool, and I'm going to split using a plane, using a plane defined by 3 points, and partition rather than split into separate geometries, as it were. Okay, so pick the solid, pick the 3 points. So this process is something I've thought about, so I can understand what's going to be involved. So I'm just specifying, excuse me, the discrete cells that we want to pick. So 3 points again. So just breaking this up into discrete cells. Okay, so we've got two regions that can be hex meshed, or discrete regions that can be hex meshed, and then finally we've got the last cell we want to hex mesh. Okay, so it's all turned green. Happy with that. So if I now go into the 2.5D meshing tool, I've got my meshing algorithm set to mapped. Let that run through, and we've got the mesh that we want. Okay, the element quality isn't great. Okay, let me show you that, and we can show that check in 3D. Okay, so we're going to do a couple of splits on the fly. So I'm going to partition, or rather boolean some of these regions back together. So I can boolean these cells. Just bear with me while we do this. These regions, there we go. Back into 2.5D meshing. Pick the solid. Okay, the element quality is better. But we've still got some bad quality elements with lots of skew and taper at the back there. So I'm going to do a further split. I'll just delete the mesh. I'm doing this for speed. And I'm going to split about these, again, these planes. So picking 3 points. Once you've done this a couple of times, it becomes very straightforward. Okay, and finally splitting here. Okay, so we've got our discrete cells. Back to 2.5D mesh, and you can now see our element quality shown really nicely here. Okay, so we've still got some poor elements, but we've got no bad and certainly got no invalid elements. Okay, it's a really quick way to develop that hex mesh for compound fillets. We can then cut and paste this into discrete regions if necessary. Here's one I made earlier, as they say. So here we've got a pretty complex geometry. So cruciform fillets in all regions. I've actually split this as well to give us, let me just show you, these bounding partition regions as well. So the elements close to the surface perfect quality or as close to cubic geometry as you can get. Okay.
I hope you found this interesting. If you'd like to develop your Apex usage, head over to our site where you'll find many online learning opportunities.